Welcome to A-Minder, a podcast where we summarize the latest publications on neurodegenerative disease research so that you can stay up to date with the newest findings. Every month, our team of scientists will sort and organize the titles into themes and present shortened versions of the abstracts. We'll make sure to mention the title, the journal, the first author, and the last author for each publication. Whether you're in the lab, on the bus, or cooking your meal, we hope you find this podcast helpful.
Hello everyone, my name's Ellen Koch and I'll be your host today. In this episode, I'll be covering papers under two major subthemes. The first being cognitive testing for the diagnosis or detection of Alzheimer's disease, and the second are papers that we sorted under unclassified detection methods. Basically, these papers are papers that didn't fit into our other subthemes for detection and diagnosis methods, which, by the way, will be covered in this and other episodes. So we threw them all together in that section. And just a reminder that all of the papers in today's episodes were published in June 2020. Also, in case you didn't know, all of our episodes are accompanied by a time-stamped bibliography. So this is really useful if you hear a paper that you want to check out more. You just need to sign up for the bibliography. Check out the show notes for more info on how to do that. So let's get started. First, let's talk about 20 papers on cognitive testing for the diagnosis or detection of Alzheimer's disease. Here we go. So in this section, many of the studies focus on how Alzheimer's disease can be diagnosed in different populations using cognitive testing, or on new and improved tools for the diagnosis of AD based on behavioral symptoms. Other papers in the section tell us about newly discovered ways that cognition and behavior are affected. I think that this section is full of really interesting papers, and I really hope you enjoy. First up, we have a paper titled Diagnosis of Prodromal and Alzheimer's Disease Dementia in Adults with Down Syndrome Using Neuropsychological Tests. This paper is in the journal Alzheimer's and Dementia. First author is Benajam, and last author Fortia. So you may be aware that there's a high prevalence of AD in people with Down syndrome. The authors of this study wanted to see how they could use normative neuropsychological data to identify prodromal AD and AD dementia in adults with Down syndrome. Participants were classified as asymptomatic, prodromal AD, or AD dementia. The neuropsychological data consisted of two assessments. The first one has a long name here. It's the Cambridge Cognitive Examination for Older Adults with Down Syndrome. And the other one is the Modified Q Recall Test. The researchers found that both of these neuropsychological assessments showed high diagnostic performance in diagnosing prodromal AD and AD dementia in adults with Down syndrome who had mild and moderate intellectual disability. This could be a reliable way to diagnose AD in this population. So our next one has a long title, so here goes. Diagnostic and prognostic accuracy of the Cogstate Brief Battery and Auditory Verbal Learning Test in preclinical Alzheimer's disease and incident mild cognitive impairment. Implications for defining subtle objective cognitive impairment. All right, I got through that one. And the first author was Stricker. Last author is Mielke. And the journal is the Journal of Alzheimer's Disease. In this study, the researchers aimed to find out whether cross-sectional performance on two cognitive tests could be used to detect AD. This was tested in cognitively unimpaired people with preclinical AD. They explored subtle objective cognitive impairment using the two tests mentioned in the title of the paper, which again are Cogstate Brief Battery and the Auditory Verbal Learning Test. See the paper for more details on the experimental methods. The participants were divided into three groups. Those that were positive for AD biomarkers amyloid and tau from imaging, which are called A plus T plus, amyloid positive and tau negative individuals, which is A plus T minus, and amyloid and tau negative, A minus T minus. All in all, they found that the cognitive battery tests could not differentiate between the different groups, but it showed potential for predicting mild cognitive impairment or dementia. On the other hand, the auditory verbal learning test was able to distinguish the A plus T plus and the A plus T minus groups from the A minus T minus groups. The next paper also looked at a few different cognitive tests and their ability to differentiate between AD and AD with Lewy body disease. This paper is titled Cognitive Tests Aid in Clinical Differentiation of Alzheimer's Disease versus Alzheimer's Disease with Lewy Body Disease. Evidence from a Pathological Study. The journal is Alzheimer's and Dementia. First author, Azar, and last author, Cosentino. So as I mentioned earlier, these researchers wanted to find ways to differentiate between AD and AD with Lewy body disease, which I'll be referring to as AD plus LBD. They looked at neuropsychological functioning and specific cognitive tests. Data from post-mortem subjects with AD and AD plus LBD diagnoses were analyzed, which came from the predictor study. Using various statistical analyses, they found some interesting differences between the groups. AD individuals were better in visio-construction, phonemic fluency, and processing speed when compared to AD plus LBD. They also discussed the cognitive functions that had no difference between the groups. This study sheds light on ways that these two diseases can be diagnosed using cognitive testing. Next, we have a paper titled Neuropsychological Profile of Amyloid Positive versus Amyloid Negative Amnestic Mild Cognitive Impairment. And I have a feeling I'm going to be using that word neuropsychological a lot in this episode. And actually, the journal is the Journal of Neuropsychology. First author is Alves, and last author is Guerriero. And again, I think I've said in other episodes, I apologize if I mispronounce any of these names. So, although biomarkers for AD, such as amyloid beta, can be detected and used to diagnose this disease, some patients don't have the opportunity to undergo biomarker testing. So these authors wanted to determine if neuropsychological testing could be used to predict whether patients with amnestic MCI, mild cognitive impairment, are amyloid positive or amyloid negative. Using data from AMCI participants in the Cognitive Complaints Cohort database, the authors tested the ability of neuropsychological tests to predict amyloid status. They found that A-beta positive patients performed worse than A-beta negative patients on a number of memory tests. Using the binary logistic regression model, the logical memory delayed free recall test was the only one that was significantly worse in the A-beta positive group, and it was 64.6% successful at classifying AMCI cases based on amyloid status. So, though there may be potential, it seems that the tests are currently not very valuable in distinguishing between the different types of amnestic MCI. The next study tests the accuracy of Spanish language diagnostic tools for AD. It's called Diagnostic Accuracy of the Repeatable Battery of the Assessment of Neuropsychological Status Update, Spanish version, in predicting Alzheimer's disease among Hispanic older adults in the United States reporting memory problems. Another long title there. Journal is Applied Neuropsychology, Adult. First author is Barnes Marrero, and last author is Castillo. The authors wanted to evaluate the ability of the Spanish version of the repeatable battery for the assessment of neuropsychological status update, or RBANS, to predict AD in older Hispanic adult populations in the U.S. who report memory problems. They analyzed the data from Hispanic memory clinical patients with and without AD. They found that the total scale score and the immediate and delayed memory index scores provided the best estimates of diagnostic accuracy when they compared these to other index scores. The authors suggest that using the optimal cutoff values for these index scores can help in the diagnosis of AD in Hispanic patients. They suggest that this is best when combined with a comprehensive assessment. In the paper, they detail the cutoff points that had the best predictive probability, so you can consult the paper if you're interested. Next up, we have the paper degree of cognitive impairment does not signify early versus late mild cognitive impairment. Confirmation based on Alzheimer's disease polygenic risk. And I think that title did a great job of summarizing the main findings of the paper. First author is Ellman, and last author is Kremen, and the journal is Neurobiology of Aging. These researchers wanted to explore the validity of using the degree of amnestic mild cognitive impairment, MCI, to determine whether patients are at early or late stages of MCI. A previous Alzheimer's disease neuroimaging initiative study had found that the degree of cognitive impairment was associated with levels of AD biomarkers, neurodegeneration, and with the likelihood of developing AD. But now, in this current study, they found that higher polygenic risk, AD risk, was associated with increased impairment on the auditory verbal learning task. What they conclude is that because disease progression doesn't affect polygenic risk, there may be many false positives in presumed early MCI cases. In the end, the authors suggest that severity of impairment on its own could inform us about disease risk, but not distinguish between early and late MCI. Now we have a paper looking at the accuracy of cognitive screens in adults in a Turkish population. It's titled, Comparison of the Accuracy of Short Cognitive Screens Among Adults with Cognitive Complaints in Turkey. Our first author is Varan, and the last author is Yavuz. Journal is Alzheimer's Disease Associated Disorders. The authors compared the accuracy for 3 short cognitive screens. These were the Mini Mental State Examinations, Montreal Cognitive Assessment, or MoCA, and the Turkish version of the Quick Mild Cognitive Impairment Screen, which we'll call QMCI-TR. Their patients were Turkish older adults, some of which had subjective cognitive complaints, and others had amnestic MCI or probable AD. They also wanted to determine suitable cutoff values for age and education level for these cognitive assessments. In the entire participant pool, they found that the QMCI-TR was the most accurate for distinguishing AMCI from AD. The QMCI-TR and the Mini Mental State Exam were both better than the MoCA or MoCA in distinguishing subjective cognitive complaints from AMCI and AD. But for low literacy individuals, it seems that all of the tests performed with similar accuracy. This means that the particular choice of test in this case is less critical. Okay, so our next paper is titled Patterns of Multi-Domain Cognitive Aging in Participants of the Long Life Family Study. First author is Sebastiani, last author is Pearls, and the journal is Geroscience. In this, I think, ambitious study, the authors used Bayesian modeling to cluster data from over 5,000 patients of the Long Life Family Study into groups based on the degrees of cognitive change in a variety of domains. These domains include episodic memory, attention, processing speed, and verbal fluency. The degree of cognitive change for each cluster ranged from rapid decline to very slow change. They determined the relationship between these clusters with measures such as genetic and molecular biomarkers, risk factors, medical history, and markers of aging. They found many interesting results, including genetic and molecular predictors of cognitive change, and that maintaining good physical function correlates with slower cognitive decline. Good to know. Using their data, they summarized all the multi-domain changes into a score of cognitive function change. There's too much to cover here, but check out the paper if you're interested in hearing more about the results. I think I will. Now let's talk about a paper on the use of web-based registries in assessing cognition. It's called Unsupervised Assessment of Cognition in the Healthy Brain Project, Implications for Web-Based Registries of Individuals at Risk for Alzheimer's Disease. The journal is Alzheimer's and Dementia. First author is Perrin, and last author is Lim. These researchers explored the utility of unsupervised cognitive testing using web-based platforms in middle-aged adults in the Healthy Brain Project. What they found is high acceptability, meaning there was only a small percentage of missing data, and high usability, in that there were very few errors and it was easy for participants to use. They found an inverse relationship between performance on the test and both test difficulty and age, which the authors took as evidence that the test was valid. Overall, this could be an accessible platform for users to undergo cognitive testing in an unsupervised way. I think that's an awesome idea, and I love hearing about new tools for people to access this kind of testing that they may not normally have access to. So that's awesome in my opinion. And next, on kind of a similar note of bringing cognitive screening to more people, we have a paper titled Community Memory Screening as a Strategy for Recruiting Older Adults into Alzheimer's Disease Research. The journal is Alzheimer's Research and Therapy. First author is PV, and last author is Salmon. So the authors of this study wanted to find accessible ways for adults to undergo cognitive testing and also be able to recruit more participants for AD research using these cognitive testing events. So the authors tested the use of periodic memory screening days, which are events in communities to provide free cognitive testing to adults 65 and older. The participants of these events were screened using the MOCA, M-O-C-A test that I mentioned earlier in the episode, and story recall tasks provided with feedback, and they were told about opportunities to participate in research. Overall, they found that those classified as likely decline were older, less educated, had memory concerns, were more likely male, and were less likely to have a family history of dementia than no decline, which is kind of the opposite of what I would expect. When they compared their procedures to full clinical evaluation, the researchers found that there was a skew towards possible and likely decline. Majority of participants screened consented to being listed in a research registry and reported interest in AD research procedures. Some participants were then recruited for ongoing studies. The authors conclude that these events may be useful for meeting public demand for cognitive testing opportunities and for recruiting participants for research studies. The next paper in this section is called BHA-CS, a novel cognitive composite for Alzheimer's disease and related disorders. First author is Troy, and last author is Pawson, and the journal is Alzheimer's Dementia. In this paper, the authors developed a new cognitive assessment tool, the Brain Health Assessment Cognitive Score, and cross-validated it in a population of cognitively normal and cognitively impaired older adults. They also looked at long-term reliability of the assessment and the association with A-beta burden in some cognitively normal participants using emission tomography. Good news! The BHA-CS was accurate, even in the long term, at detecting cognitive impairments and decline. In the cognitively normal group, the A-beta positive group had worse longitudinal performance than the A-beta negative group. So, this test is sensitive enough to detect cognitive decline in preclinical and prodromal disease stages. Next, a paper using machine learning to look at the use of clinical biomarkers in AD diagnosis. It's called Machine Learning Models Reveal the Importance of Clinical Biomarkers for the Diagnosis of Alzheimer's Disease. The journal is Studies in Health Technology and Informatics. First author is Rafei, and last author is Alum. This summary is short and to the point. The authors propose a machine learning technique to differentiate between subjects with no cognitive impairments, mild cognitive impairment, or AD. They hope this tool can be used to understand how different clinical measurements contribute to the diagnosis of AD. They tried many different machine learning techniques and found that gradient boosting decision trees worked the best in distinguishing between the three groups based on clinical measurements. The abstract doesn't go into a lot of detail, but if you're interested, check out the paper after the show. On a similar topic, next up, a paper titled Using Unsupervised Learning to Identify Clinical Subtypes of Alzheimer's Disease in Electronic Health Records. First author is Alexander, and last author is Dinaxis. Oh, and I don't actually have the journal here, so let me quickly check which journal this one is from. Okay, I found the journal. It's the journal Studies in Health Technology and Informatics. These researchers used the unsupervised learning approaches, MCA and K-means, to try to determine clinically meaningful patient clusters for AD subtypes from the UK primary care electronic health records. They found 5 clusters, which they characterized as typical AD, non-typical AD, mental health, cardiovascular disorders, and men with cancer. Interestingly, disease progression was faster in the mental health cluster, making this an important target for research. This paper shows the utility of using these unsupervised learning approaches to better understand and identify subtypes of AD. Moving on to a paper titled Assessing the Utility of Language and Voice Biomarkers to Predict Cognitive Impairment in the Framingham Heart Study Cognitive Aging Cohort Data. First author is Thomas, last author is Hosseini Gomi, and the journal is the Journal of Alzheimer's Disease. This paper aimed to use recorded voice features as proxies for cognitive function. They wanted to develop diagnostic methods for cognitive decline that are efficient, accessible, cheap, and accurate. That sounds great to me. They analyzed the 170 audio recordings and transcripts, paired with results from neuropsychological tests from 135 patients in the Framingham Heart Study. They correlated cognitive performance measures with acoustic and linguistic voice features. Many language and voice features had good correlations with cognitive performance and good predictive power with testing results and diagnoses, and this includes dementia diagnosis. Some examples with good predictive power include the mean spectral slope in the 500 to 1500 Hertz band, demographic features such as employment and education, and text features like the number of words and word complexity. These results are promising, and they aim to do a follow-up study with the entire Framingham Heart Study cohort. Continuing with the topic of speech, next up we have a paper called Quantifying the Uncertainty of Parameters Measured in Spontaneous Speech of Speakers with Dementia. The journal is the Journal of Speech, Language, and Hearing Research. First author is Ossaward, and last author is Bastians. This is another paper implementing machine learning approaches to help in dementia research. Machine learning approaches usually use large amounts of data compared to traditional clinical methods, and this large amount of data reduces uncertainty in the analysis. The authors wanted to determine the best text length to reduce uncertainty when using machine learning approaches to analyze spontaneous speech in speakers with dementia. They used the Stanford parser to extract linguistic elements and trained a statistical model to distinguish between probable AD and cognitively normal participants. They identified 6 different linguistic variables and determined the level of uncertainty for them. Sorry, I've been learning a lot about machine learning in my own work and using machine learning tools, but I'm not an expert, at least not yet, maybe one day. So you'll have to look at the paper for the technical details. However, using their model with a German text, they determined that about 700 words seem to be the optimal sample length. So that seems like a really good thing to know when using these machine learning approaches for this kind of work. Interesting. Okay, next up is the paper Predicting Alzheimer's Disease Based on Survival Data and Longitudinally Measured Performance on Cognitive and Functional Scales. First author is Wu and last author is Yu, and the journal is Psychiatry Research. The aim of this research was to determine the ability of longitudinally taken cognitive and functional scales to predict the conversion from MCI to AD. The participants all had baseline MCI and were all part of the Alzheimer's Disease Neuroimaging Initiative. 4 common AD assessment scales were included in the study. These were the AD Assessment Scale Cognitive, which is also called ADAS-COG, numbers 11 and 13, the Mini Mental State Exam, and the Functional Assessment Questionnaire. Using statistical techniques, they assessed the predictive accuracy of these scales. They found that all tests had statistically significant results and that the Functional Assessment Questionnaire had the best predictive accuracy. Again, see the paper for more details on their statistical techniques. The author concluded that cognitive and functional scales are useful tools in identifying AD risk. Maybe it's a good time to remind you that we have the timestamp bibliography for each episode, so you can easily find all the papers we cover. The next study is titled Allocentric Coordinate Spatial Representations Are Impaired in AMCI and Alzheimer's disease patients. The journal is Behavioural Brain Research. First author, Ruggiero, and last author, Iachini. Egocentric spatial representations involve subject-to-object spatial relationships, whereas allocentric refers to object-to-object spatial representations. Deficits in both types are present in early-stage AD and even in individuals with amnestic MCI. Two types of frames of reference were the topic of this research: coordinate, which uses distances, for example, or categorical, which is more abstract, such as right or left. The authors were interested in how the allocentric deficit is affected differently when it's combined with categorical or coordinate frames of reference. Early AD and MCI patients were compared to healthy controls. They found that both early AD and MCI patients had deficits in the coordinate allocentric judgments, but not in categorical ones. In normal life, this could translate to patients with AD having difficulty representing and comparing distances between objects in space. That's pretty interesting. All right, so moving on, we have a paper called Impaired Integration of Object Feature Knowledge in Amnestic Mild Cognitive Impairment. And this is in the journal Neuropsychology. First author is Korthauer, and last author is Vesta. On a similar kind of theme to the last paper, this one is on the topic of the integration of object features to create representations of real-world objects. In AD, since many neocortical areas are pathologically affected, the authors hypothesized that this neuropathology would affect the integration of object features, leading to semantic memory deficits. With healthy adults and patients with AMCI, they assessed feature integration using two experimental tests. They found that MCI patients had a selective integration deficit when making judgments on living but not non-living objects. This was consistent with deterioration in semantic structural representations, according to the authors. In some patients who also had PET imaging done, they found a relationship between the degree of impairment and the cortical amyloid burden. So they conclude that impaired integration of distributed semantic object representations could be a sensitive marker of early AD. Our second last paper in this section is on a different type of behavior now, on gait disturbances. It's called Gait Disturbances Are Associated with Increased Cognitive Impairment and Cerebrospinal Fluid Tau Levels in a Memory Clinic Cohort. First author is Merling, and last author is De Boer, and the journal is Journal of Alzheimer's Disease. In this paper, the authors wanted to know how gait features relate to AD pathology and which are most informative. Comparing between cognitively normal, MCI, and dementia patients, they tested features of gait, the correlation with cerebrospinal fluid markers of AD, and whether these gait features can predict cognitive decline. They used accelerometers attached to lumbar vertebrae in participants while they completed a walk and a dual task. Dementia patients had lower PACE scores than MCI and cognitively normal, and they discovered a relationship between rhythm and CSF tau levels in the dual task. However, gait wasn't associated with CSF A-beta levels or with cognitive decline. To wrap up this section, we are switching gears to an animal study, and I actually work with animal models of Huntington's disease in my own work, so this paper is about a rat model of Alzheimer's disease. So it's nice to see some animal model papers in this section as well. So this paper is called Behavioral Phenotype in the TGF344AD rat model of Alzheimer's disease. First author is Sari, and last author is Smith. The journal is Frontiers in Neuroscience. These authors created a new rat model that they call TGF344AD. In this model, both sexes show age-dependent A-beta buildup. There's some interesting sex differences in this model as well. Female mice were hypoactive at 6 and 12, but not at 18 months in the open field, but male mice didn't show this phenotype. Learning and memory were impaired in both sexes, And males, but not females, showed hyposmia phenotypes, which is a new word for me. This is a deficit in detecting odors. And the paper goes into more detail on the behavioral phenotypes of these mice if you're interested. This animal model could definitely be useful in studying early behavioral markers of AD. And with that wraps up the section of cognitive and behavioral testing for the diagnosis and detection of AD. Okay, so moving on to unclassified detection methods, we have a handful of very interesting papers in this section. Starting with a paper that looks at a variety of prodromal disease symptoms, we have comparison of prodromal symptoms of patients with behavioral variant frontotemporal dementia and Alzheimer's disease. The first author is Korhonen. Last author is Solj, or Solj. And the journal is Dementia Geriatric Cognitive Disorders. As the title gives away, these authors compared the prodromal symptom profile between patients with AD and those with behavioral variant frontotemporal dementia, which I'll be referring to as BVFTD. This is the most common type of frontotemporal degeneration. This dementia is often misdiagnosed and has clinical overlap with AD. They compared patient records from patients with either AD or BVFTD. Both groups were likely to have subjective memory disturbances, though AD patients were more likely than BVFTD. Many symptoms were more common in BVFTD patients. That's surprisingly hard to say, including physical symptoms such as headache, sleep disturbances, and psychiatric symptoms such as delusions and suicidal ideology. Check the paper if you're interested in more of the differences that they found in the symptoms of these two diseases. Hopefully, by better characterizing these differences, we can avoid misdiagnoses and provide better care to patients. Next, we have a few papers on the retina and visual system in AD. The following 3 papers all use optical coherence tomography, which is a tool increasingly being used in AD research to detect early biomarkers of the disease that can be observed in the structure of the retina. I don't do work on the visual system myself, so if you do, please bear with me on the details of these next few papers. I'll try my best. First up, macular thickness decrease in asymptomatic subjects at high genetic risk of developing Alzheimer's disease, an OCT study. First author is Lopez Cuenca, and the last author is Ramirez. The journal is Journal of Clinical Medicine. The researchers in this study were looking at retinal thickness in different layers of the macular region and of the peripapillary retinal nerve fiber layer, both of the retina. They used optical coherence tomography, which I'll now be referring to as OCT, in healthy subjects and those with genetic risk for AD. They found that patients with family history and genetic risk of AD had reduced area of many of the different layers of the macular region. And you can check the paper or even just the abstract for more information on the details. No differences were found in the peripapillary thickness of the retinal nerve fiber layer between the groups. And they found that the earliest changes seem to appear in the macular area. Thus, this method could be a useful and non-invasive way to detect early stages of AD. Now we have a paper titled, Optical Coherence Tomography Reveals Light-Dependent Retinal Responses in Alzheimer's Disease. The first author is Bissig, and the last author is Bernard, and the journal is Neuroimage. This paper explored the use of OCT again, and more specifically, what's called spectral domain optical coherence tomography, which I'll be calling SD-OCT. These authors first wanted to validate the use of functional retinal imaging with a commercially available SD-OCT device and clinical protocol. I find the methods particularly interesting. They acquire images by cycling lights on and off repeatedly, and look at light-dependent increases in the reflectivity on the inner and outer segments of the retina. They discuss a lot of interesting ideas in their abstract, including a potential role of glial cells in the changes in reflectivity. But getting to the point regarding AD, they found that early onset AD patients had exaggerated light-induced change in the avascular outer nuclear layer reflectivity. And it only took them 30 minutes to do these measurements, so this could be another easy way to detect early signs of AD. And again, on a similar vein, we have a paper titled Optical Coherence Tomography Angiography as a Potential Screening Tool for Cerebral Small Vessel Diseases. The first author is Lee and the last author is Kim, and this one is published in Alzheimer's Research and Therapy. These authors use a novel variation of OCT, which is called Optical Coherence Tomography Angiography, and they refer to this as OCTA. This technique allows them to look at radial peripapillary capillary network density and the retinal nerve fiber layer thickness. Their goal was to compare changes here to brain imaging markers of neurodegeneration. They did this in 3 groups of participants: patients with amyloid-positive AD-related cognitive impairment, patients with subcortical vascular cognitive impairment, and amyloid-negative control patients. They found many differences between the groups. Interestingly, the subcortical vascular cognitive impairment group showed lower capillary density in the superior and temporal quadrants compared to the AD-related group. The thickness of the retinal nerve fiber layer was the same in all groups and didn't seem to relate to cortical thickness. They don't go into a lot of detail on the other changes in the AD group, in the abstract anyways, but look at the paper if you're interested. Now, moving away from OCT, the next paper is still looking at features of the eye, but in this case, it's the lens. This paper is called In Vivo Quasi-Elastic Light Scattering Eye Scanner Detects Molecular Aging in Humans. Wow, quasi-elastic light scattering eye scanner. That sounds pretty cool to me. Our first author is Minayeva, and last author is Goldstein, and this journal title is a bit of a long one. It's the Journals of Gerontology, Series A, Biological Sciences and Medical Sciences. In the human lens, there are proteins present that are expressed from fetal stages that don't experience turnover and accumulate molecular alterations that can be measured in vivo. This paper describes a new tool to measure age-dependent signals in the lenses of healthy subjects. Using quasi-elastic light scattering, they found that signal changes detected in vivo could recapitulate the time-dependent changes to many features of human lens proteins that are observed over time in vitro. The author suggests that this tool could be a non-invasive way to assess molecular aging in patients. Our next paper is switching gears now to the olfactory system. It's called Olfactory Testing Does Not Predict Beta Amyloid MRI Measures of Neurodegeneration or Vascular Pathology in the British 1946 Birth Cohort. And this one is published in the Journal of Neurology. First author Buchanan, last author Schott or Scott. These authors were interested in the use of olfactory identification deficits to predict cerebral beta amyloid status and other biomarkers in cognitively normal older adults. They recruited participants from the MRC National Survey of Health and Development and used the University of Pennsylvania Smell Identification Test. About 65 of the participants had hyposmia, the reduced ability to smell. Wow, I didn't realize it was so common in older adults. And a small number had lost the sense of smell completely. In the end, their results were negative. There was no association with any of the biomarkers of interest, which include beta amyloid status, various brain structure changes, or cognitive markers. And last but not least, we have another machine learning study titled Predicting Onset of Dementia Using Clinical Notes and Machine Learning, Case Control Study. This is published in JMIR Medical Informatics, and this one is by first author Hain, and the last author is Bleacher, sorry, I'm not sure how to pronounce that one. These researchers wanted to use clinical notes to train machine learning models that predict the risk of Alzheimer's disease and related dementias. They had 10 years of data from different hospitals, which they separated into 2-year groups to train the model. They de-identified the clinical notes and found clusters of related terms and abbreviations, as these would often differ between clinicians and hospitals. Including the clinical notes improved the model's accuracy, including improving the area under the curve and positive predictive value of the model. Apparently, this depended a lot on the volume of clinical notes they had. Years with more notes showed the biggest improvement for the model. Overall, this seems like a viable tool to make use of clinical notes, when they're available, to predict the onset of dementia. Okay, and that's the end of the episode. I hope you found something that could help your research, or at least found something that you found interesting. I definitely learned many new things hosting this one. So thanks for listening, and stay tuned for a few words from Sarah. Goodbye.
That's it for this episode. A huge thank you to the team that is working on sorting, summarizing, and scripting these abstracts, as well as the operations behind AMinder. The music is from Journey of a Neurotransmitter by Anusha Kamesh, musician and fellow scientist, and now a member of the AMinder team. You can find the original piece and her other music on SoundCloud under Anusha Kamesh or on her YouTube channel, AK Music. Interested in joining the team? Give us a shout! We can always use help with content development, podcast editing, advertising, and you can be part of a new and exciting venture. Reach us by email at aminderpodcast@gmail.com or follow us on Twitter. Oh, we're also on Facebook now. Don't forget to subscribe to our mailing list if you want access to the bibliography for each of our episodes. The references come with timestamps. Timestamps. So you can more easily locate the paper that caught your interest. Check our notes below for details on how to sign up. And very close to this, you'll also find a link to our feedback survey. Because, yeah, your feedback matters to us. So please, pretty please, let us know how we can make this podcast a better tool for you. And last but not least, thank you for tuning in with us. And on this note, we hope you found our podcast useful and accessible. Until next time.